we're going to want to check on a regular basis as part of our maintenance. And just a general word about maintenance, you want to do maintenance on the NetBrain system, which usually involves just checking through things and then seeing everything's okay. But we want to make sure that we're doing this on a regular basis. So you want to do it at an absolute minimum once a month. That's your absolute total minimum. You really want to do it at least once a week. By preference, especially if you're in a particularly active network, once a day. And like I said, usually this is just a matter of taking a few minutes to check over, see that there's no problems, and that's it. But you need to keep up with this on a regular basis. NetBrain is not a set it and forget it system. What it's doing is simply too complex for that. It does require some TLC. And when it does encounter errors, sometimes it's an error with NetBrain. More often, it's a sign that something's actually gone screwy with a device. And then that alerts you before anything else. But regardless, you need to keep on top of this because there is nothing worse. If speaking from a NetBrain point of view, there is nothing worse than having a network issue, going to NetBrain to help you see what the issue is, and then realizing that you need to troubleshoot NetBrain before you can troubleshoot the device. If that's happening, NetBrain's not being useful. So anyway, NetBrain can deal with duplicate IP addresses and subnets, and it does this by means of what are called zones, which are arbitrary levels of complexity within the network environment. So we see that there's some that are auto-generated by the system, some that are auto-generated per particular technologies or via QApps or things that we've created manually. So nowadays with the open topology framework, this basically takes care of itself. So I'm not going to dwell on it, but just know that this is a thing. And the way that we check it is we come in here, we make sure it's set to all zones and that this box is checked to only show zones with conflicts. And if that's the case, then we should see exactly this, a blank screen. Discover MAC list, black MAC list. These are lists of MAC addresses that NetBrain is going to mandate or prohibit, respectively, in the discovery process. Now, why it would do this, I don't know the use case around either of these. I'm sure there is one, but they're relatively new, and I haven't heard what they're for. Topology Link Manager. This is where we can view and edit our calculated topologies. So if you've ever wondered what a NetBrain topology looks like, well, feast your eyes. This on this device connects to this on this device. This on this device connects to this on this device, and so on. This is our topology, and so we can view it here, obviously, fully. And then we can lock down any entry in the topology, which means it's not going to get changed or deleted until we come back and unlock it or do it manually. We can manually add links to the topology, which NetBrain will believe. Excuse me. NetBrain will believe our additions regardless of what the devices say. And then we can also disable links, which NetBrain will then, again, with Sergeant Schultz, I know nothing. It will pretend they don't exist regardless of what the devices say. So feel free to completely manipulate your topologies if needed. Cloud Manager. Let's switch back to the slide deck here. So we talked about all that. All right. So there's there's a couple different types of cloud objects that we can create. 3 of them, at least in my deployment, are, or is it 4? All but 2 basically are for specific vendors to represent parts of the topology that we don't control. And so for those vendors, I'm assuming anyone who's familiar with the technology will understand what you're supposed to do with them. The two I'm going to speak about are the general use ones, MPLS cloud objects and internet cloud objects. MPLS cloud objects are to represent MPLS clouds that are not under our control, but still are part of our NetBrain or rather our network environment. So to put it a little bit more technically, we use the cloud objects here if we are the customer only for the MPLS setup. If we are both the customer and our own provider, or if we're only the provider, we do not need these objects. So what it is it's saying, okay, here are the customer edge or CE devices and interfaces that face into this cloud. You can either manually specify what they are, and or you can create a series of search parameters, either just by specifying a BGPAS number is a very common thing to do, or you can create a whole interlocking series of different criteria that tells NetBrain which devices, and more specifically which interfaces, the cloud connects to. And then whatever list of CE interfaces it comes up with, it's going to say, okay, all of these face onto the MPLS cloud logically, so let's show them as being connected. Now, we can then have the cloud object take the route tables of all of the facing devices and calculate what's called the virtual route table for the cloud, which allows the A to B path calculator to path across the cloud from point A to point B by assuming that everything is working on the ISP's end. And this is very, very nice for visualizing connectivity between sites, for example, if you are using an ISP. And then I like to joke that internet cloud objects are the NetBrain equivalent of writing "Here There Be Dragons" on the edge of your map. So what I mean by that is all this is just saying, hey, this is the edge of our network that we control, and past here is the internet. So you attach them to one or more specific devices and interfaces, just like the MPLS clouds. And so whether you've got, for each outside facing interface, whether you have a separate internet cloud object or whether you have them all face into the same cloud or anything in between, all that's going to affect is how it's going to show up on a map when you've extended things. So do whatever makes sense for you. Now we can actually link the internet cloud objects to specific static IP addresses, so that when we try to path from those IP addresses or to them or search for them, the internet cloud object will show up. And so it can, again, the trace isn't going to go beyond the bounds of our discovered network, but we can kind of represent it being out there in the internet somewhere by attaching the IP address to this particular, to a particular cloud object. So those are the different types of clouds. Any questions on these things and what they're for and so forth? All right. So let's just take a look at what the GUI looks like real quick. Okay. So if I go in here and I edit this, okay, so once you've named a cloud, you can't rename it, so just be aware of that. So with the dynamic search, I can search by an AS number, or I can specify complex criteria with an advanced search. And what's nice about dynamic searching, of course, I can, of course, just statically assign stuff, and you can do a mix. What's nice about dynamic search is then you can have NetBrain reassess the membership, the facing devices, as part of its system benchmark, and then things will automatically adjust, which is pretty cool. Now, with an MPLS cloud, the first time you have to generate the virtual route table yourself the first time, but then once you've done that, the virtual route table should show up like this, and NetBrain can use that for pathing purposes. Okay. And then as far as what other types of What's up?
One quick question, and then actually I'm the one who has to drop. You can use, so if you are a campus and you have multiple ISPs and you receive BGP feeds from those ISPs, if you set each ISP up as a cloud destination, you can then in theory look to see, like, so if I'm trying to get to my campus to Google, I can see which cloud provider, which ISP is sending me a route for Google at what time?
Yes, basically, assuming that all the relevant information is available to the path calculator, it will show you which cloud it actually is being sent to.
Oh, okay, that's kind of cool.
Which can be pretty cool.
If you're multi-homed, this would help answer a question of like, all right, where did my traffic go out? Which ISP did my traffic go out at any particular time?
Yep, assuming that all of the information is available to make that determination, yes. Also, with your if you mean by Google, you mean like G Cloud. If you can actually in later versions of NetBrain, you can discover your G Cloud, AWS, Azure into NetBrain, and so you see use this MPLS cloud to kind of bridge that gap and be able to actually, it'll pick it up back inside your G Cloud environment and trace within that as well.
Oh, okay. All right. Yeah, I was more thinking about like, how do I get to an IP address on the internet? Which of my providers will I transit?
So okay, to get to the internet, that's going to be a harder determination. It'll try. It'll probably dead end in the MPLS if it's going out to the internet. I'm not sure, or if it comes up with a route of last resort for this, I should think that'll determine where it spits it back out into your internal network. So it's kind of making assumptions. If you want to simulate a static IP address just being out in the internet, you would use an internet cloud object and then assign that static IP address to it.
Oh, okay. Gotcha. Okay.
And it'll say, okay, it's going from this device out to the internet to this IP address, and you'll know it at least got out of your network correctly.
Okay. All right. I see what you're saying. Okay, cool.
Yeah, it's, we can't interpret data we can't access. So any other questions before you have to drop, Brian?
Nope. Also, thank you very much. I appreciate it.
All right. Have a wonderful day. So I do have you on the screenshot. I will mark you present later. And so please later today or tomorrow, don't forget to fill out the post-class survey.
Will do. All right. Thank you.
All right. Later. All right. So next, are any other questions before we move on from anybody? All right. So next, generic devices. Generic devices is just a way for us to manually say, okay, I have a device of this type and this driver. Here's its host name. Here's its management IP address. Here's its interface info. And NetBrain will believe us. It will take a node license to add this, but then it will incorporate this into the topology when the topology is recalculated. So we can just add either theoretical or real devices manually like this. And then if it is in fact a real device, we can later point NetBrain to what credentials to use and so forth. And once it starts talking to the generic device for real, then it will start pulling detailed information and adjust as needed. So there's that. Next, this is very much a maintenance thing, hostname changes. To be very brief and oversimplistic, NetBrain can deal with changes to just about any aspect of a device's configuration except its host name. The reason is that the host name is the key value in the key table in that part of the NetBrain database. So when a device changes its host name, we're going to need to do some jiggery-pokery in the database to make sure that there's no problems. So it double checks it against the serial number for the device. So first of all, we need to come in and make sure that an identified change is in fact legitimate. If not, we can get rid of this stuff from the table. If it is legitimate, we select the serial number that, here's before, here's after, and we say keep the latest. So it's going to remove all data and records associated with the old host name, but it will then recreate all of that as new entries in the respective tables, and those new entries will be linked to the new host name. So we're not losing our data. So that's pretty fantastic. Next, data migration tasks. We can see what is going on and what its status is, and start, stop it as need be. And finally, if we've run a discovery and we've run out of node licenses, NetBrain will continue discovering up to about 100% of node license capacity by default, although you can adjust that somewhat. And what this does is it's not going to like actually pull detailed information. It's just going to say, oh, here's a list of devices I could have discovered in addition if I'd had the node licenses. So this is great for assessing how many more node licenses we actually need to buy if that comes up. Okay. So that's fine-tune. Next, let's talk about sites. There's two types of sites. So what are sites? Sites are geographic groupings of devices, as you say here. They're logical groupings of devices based on geography. So a device can only belong to one site at a time. And there's actually two different types of sites. There's container sites, and these are for fleshing out the topology. The devices don't actually get assigned to a container site directly. Instead, they get assigned to a leaf site, which is where the devices actually live. So let's go ahead